Well, good morning, everyone. Um, Welcome to our session today. The title of our panel today is Modeling Human Behaviors After an Act of Targeted Violence. My name is Matthew D. Michelle, and I'm a sociologist here at RTI, where I direct the Center for Criminal Legal Systems Research. And I'm really excited to be here today to present this project to facilitate this panel and this presentation today. And before I introduce our panelists and turn it over to them, I'm going to say just a couple of words on kind of some of the background for this project. 'Cause it was a really exciting project. And I think hopefully you all find it really interesting as well. But here at RTI, we've been working with Department of Homeland Security's research arm, Science and Technology Directorate, for many years, mostly focused on terrorism prevention and intervention programs and doing a lot of evaluation for them. And then one day, one of our colleagues there at S&T came to us with a question that they had been hearing from one of their partners at DHS in the Office of Bombing Prevention. For those of you that don't know, the Office of Bombing Prevention is in charge of conducting trainings across the country on the intervention and prevention of bombings. And they train about 25 to 26,000 people each year. But during these trainings, they continue to get a question about what do people do after a bomb goes off in a crowded place or a soft target? How do humans actually behave after the IED functions or detonates? And so much of their work had focused on prevention and intervention that they didn't really have an answer for these folks that were going through the trainings. And so they came to us and asked us if we could help devise a research project to provide some kind of systematic, empirical evidence for them on what people do or do after a bomb goes off. And so myself, Reiner, and several other folks, we kind of pulled together a group of social scientists and data scientists here at RTI to kind of think about how could we conduct some experiments or conduct some research to understand what people do after an IED functions. Of course, as a social scientist, I threw out the idea of a randomized controlled trial. Could you randomly place a bomb somewhere and not somewhere else? Thank you. I'm glad you laughed. Of course, we didn't propose that. Uh, um, but we kicked around these different ideas of what kind of research strategies could we design. And so Reiner and some of his data science colleagues, they came up with the idea of we could run a simulation and we could use the statistical infrastructure known as agent-based modeling to essentially simulate a whole group of folks, like 20,000, 50,000 people at a large stadium, at a sporting event, or at a large concert, right? Because that's where these events, these soft targets, essentially these public spaces, are attacked by terrorists and extremists. I mean, we saw this in Manchester. We saw this at the Boston Marathon many years ago, London, Madrid, and the trains. So on and on. I mean, there's plenty of evidence for how these terrorists are using these soft targets to convey a message of fear, if you will, and really do a ton of damage and devastation and injury through these attacks. So we began working with Reiner and his colleagues in data science to build this agent-based model simulation. And so in today's presentation, Reiner and Will are going to walk you through how we put this together and what it means and kind of what are the policy and practical implications of this research. So with that said, I'm going to take just a minute to introduce our three panelists. First, we have Dr. Will Parkin, and Will is a senior research analyst here at RTI. He is in the Security Threats and Extremism program, and he's been at RTI just over 2 years now. Will came to us from Seattle University, where he was an associate professor of criminal justice, criminology, and forensics. And Will has spent his entire career researching and studying and developing policy implications on issues related to terrorism and extremism. He has studied far-right extremist violence. He's worked on the nationwide suspicious activity reporting initiative, and he's worked with dozens and dozens of police departments working on different community policing initiatives. Next to Will is a colleague of mine, Dr. Reiner Hilscher, who is a senior research data scientist here at RTI. And Reiner has been at RTI for just over 10 years now. And prior to coming to RTI, Reiner worked at the Center for Social Epidemiology and Population Health at the University of Michigan. Reiner has a very interesting background. Will does as well, but Reiner's is focused on simulation modeling, artificial intelligence, and a whole host of data science projects that he leads here at RTI. And then lastly, our third panelist, and no, I'm not having any problems today. Our third panelist is on the phone, actually. And our third panelist is Dr. Nathan Meehan. And Nathan is a behavioral scientist and support contractor at the Department of Homeland Security Science and Technology Directorate. There at, or prior to going to S&T, Nathan was the Director of Research and Development at Second Sight Training Systems, where they develop trainings, a host of trainings for law enforcement and military personnel. And prior to his time at Second Sight, Nathan worked for 6 years as a social scientist at the United States Naval Research Laboratory, where he worked on a host of projects for the Department of Defense, Department of Justice, and Department of Homeland Security. So if you take a minute and welcome our panelists today.
Okay. Well, where we go?
And with that said, before I turn it over to them, of course, you heard the announcement that they'd like to take questions throughout their presentation. You'll have plenty of time for Q&A today. And don't worry, the panel and I have agreed. We recognize we have the dubious distinction of standing between you and lunch, and we will be sure to end at 12:30. So thank you very much.
Will.
Thank you, Matthew. So I'm just going to start by giving you a quick overview of what we're going to talk about during the presentation, so that as we get to these different parts, you can kind of understand how they all fit together. So we'll talk a little bit about the project overview. Matthew gave a pretty good description of that already. And then we're going to talk about case studies that we did to collect data so we could actually do the computer modeling that we worked on. And we'll talk more about that, specifically about how you can think about modeling human behavior within a simulation environment. We'll talk a bit about agent-based modeling, which is specifically the type of modeling that we worked on. And then we'll show a simulation example. Unfortunately, we can't show the partners that we're working with right now because we have NDAs with them, but we're going to show a simulation of the Boston Marathon bombing that we did as a proof of concept as we were working through all the steps for the modeling. And then we'll talk about the key takeaways that we have so far with the we've done 2 outdoor sites right now, pretty large venues that host sporting events. And so we'll talk about some of our outcomes for that and the key takeaways from that. And then we'll also talk about other applications in addition to the IED modeling that we've been working on. And as we said, anytime you have questions, please interrupt us if you need us to explain anything differently. So just as a project overview, I think Nate is going to talk a little bit about DHS and S&T's role in this and OBP. So Nate is there.
Hello, everyone. Can you hear me?
We can, Nate, yes.
Okay,
Yeah,
excellent. Thank you very much. So I'm happy to be here to share with you some feedback from DHS, S&T, and the Office of Bombing Prevention about the great work that Will and his team are doing. I'm a behavioral scientist and support contractor at the Public Safety and Violence Prevention Program at the Mission Capability and Support Office of the Science and Technology Directorate. I know that is a big mouthful. I'm also a researcher, and I appreciated listening to the last presentation on community and police best practices for collaboration. I worked at the local level as a lead crime analyst, and that sort of collaboration and community-based practitioners discussed they are key to violence reduction. I'm also sorry that I couldn't be there in person. We had a COVID outbreak in my whole household last week, and I didn't want to be the cause of a super spreader event. I look forward to providing context and answering questions to the best of my ability. Before we move on with the presentation, I wanted to share a little bit of information about the funding for this project, as well as the work of the Public Safety and Violence Prevention Program. This project is funded through what we call the CISR program, which is the Critical Infrastructure Security and Resilience Research Program. In November of 2021, about $157 million was allocated to DHS&T to conduct research and development for critical infrastructure protection on a range of topics, including public safety and violence prevention, to evaluate soft target security, including countering IEDs, events, and the protection of critical infrastructure. The goal of the CISR program is to strengthen, maintain, and secure functioning and resilient critical infrastructure through science and technologies. If you'd like to learn more about CISR, you can visit our website, and you'll see that links are provided here in the presentation. I work at the PSVP program, and we're the implementers of a variety of scissor-funded social science research programs. We conduct evidence-based research and evaluation to understand the evolving threat landscape and prevent acts of terrorism and targeted violence. Our work involves social, behavioral, and economic sciences research to meet policy, operational, and public needs with the hope of improving the effectiveness of public safety and violence prevention efforts implemented at the federal, state, local, tribal, and territorial level. We do this through evaluation research, capability development, and the kind of work that we're talking about here today. We also have a variety of resources available from all the projects that we've funded at the Prevention Resource Finder, which is also available in the presentation. I will turn the mic back over to Will, Matt, and Reiner, and I appreciate the opportunity to be here and answer any questions that I can. Thank you very much.
Thank you, Nate. So a little bit more about the project overview. So Matthew talked about, the Office for Bombing Prevention. They do a lot of training, thousands of people a year, hundreds of different sessions. And a lot of times they have people who will come up to them after the training and say, okay, this training's really interesting. Can you tell us what we could expect if a explosion happens, if a IED functions after? How can we prepare for that? And OBP said, well, we don't really have an answer for that. And so that's where kind of the impetus for this research comes from. It's a very simple research question that was not simple for us to necessarily figure out how to do and to implement, but what do people do after an IED functions at a soft target in crowded space? And a soft target being just a place where a lot of people will spend time. It's not a hardened target. It's not a military complex. Malls, transit places, sports venues, places where we go out, schools, religious institutions. So places where we go out in public and we don't have people, law enforcement who are there always protecting us. And so what we decided to do was with them, we have 4 partner sites. So these are environments and locations throughout the country that they were willing to partner with us and talk to us about their security concerns. They would talk to us. We went to all the sites and they would show us around. They were able to give us some information about schematics on their buildings, what happens when they host events, what does the crowd look like there. And so we were able to use that information as a baseline as we were building our project and building out those sites. And so we can talk a little bit about kind of general what those sites are and what they were doing and how they helped us. We can't talk obviously specifically about them. But so the scope of the project initially was with one site, I believe, and then we got some additional funding to expand to 4. We're now working on a next phase of the project where we're going to look at a multi-modality attack. So in addition to IEDs, we're going to add an active shooter into the situation and model that. And to do this, we had to figure out, though, how do people actually respond? What happens after an IED functions? And so I'm going to talk a little bit about the case studies that we worked on and how we collected information from that. And one of the things I did want to say is we're going to show some video of real IED events. So right before I show that slide, I'll let you know in case for some reason you don't want to watch that. But I just want to let people know that that would be coming up in a few slides. So for the case studies, we had to determine decide a way how we could actually figure out what was going on after an IED functions. So some of the things we had to figure out would be how people actually react. Do they flee? Do they hide? Do they work in groups? What happens if you're there with your family and an event occurs? What happens when law enforcement is there helping out? And the modeling technique that we use, we're able to have different types of what we call agents, which are just different groups of people that have different types of behaviors afterwards. So part of the case studies was looking at real events, collecting as much information as we could about them, and then trying to determine what people would do. And so we do have a report on that, and that's a QR code. If you want to look at the report, I also have the link there. But so some of the things that we were looking at for that would be trying to track down and understand through a bunch of different data sources what actually occurred in these events. Now, these are selected. Yeah. Is there a question there? Oh, yeah. Sorry. Yeah. Put the QR code up and then go to the next slide. So we picked 6 case studies that obviously it's a purposeful sample. It's not representative of all attacks, but these were pretty large terrorist attacks where we were able to get a lot of information about what people were doing. And this information could be video evidence, it could be eyewitness statements through the news, court documents, inquests from governments. And so what we were able to do is go in and pull all that information. So what we landed on when we were trying to pick these were the Centennial Olympic Park bombing in Atlanta, the 11M commuter train attacks in Madrid, Spain, London, the Boston Marathon bombing, which you'll see. We'll show some video from that. It's one of the events that unfortunately has very good footage of people's reactions to the IED functioning because there was a camera right at the finish line as it was occurring. And then the Brussels airport and subway bombings, and then the Manchester arena bombing. And so all of these attacks were ones that we were able to get online, find video evidence, social media video of people reacting. Atlanta's kind of an outlier. It was long, it was so long ago there was not social media and camera phones. But there actually was some news video from that. Somebody was actually being interviewed live on the news when it detonated. So these were the 6 cases that we looked at. And to get information on it, what we did a lot of open source documentation searching, so journalistic accounts from the news. With Spain, we went in and we found Spanish accounts and were able to translate those. A lot of government document information, especially in the London bombings. There was a official inquest by the government. So there are actually hundreds and hundreds of pages of eyewitness accounts of what happened afterwards. And through all this information, we were able to collect data and determine what we thought people were doing, when they were doing it, how close to the explosion was occurring, were the behaviors that were different if you were trained in some capacity. So EMTs, first responders, law enforcement, what did their behaviors look like compared to citizens? Did citizens' behaviors change if there was a law enforcement officer or somebody with some authority there who was helping to facilitate what was going on? What happened when they weren't there? How did citizens then help with that? So we collected all this information, and what I'm going to show is just some snippets of videos. And so the next slide is going to have the video of the events, and I'll kind of talk through some of the information that we would pull from it. So the first one is the Boston Marathon bombing. And as I said, this is one of the events that we were able to actually get a really good idea of how people reacted immediately after the IED detonated. We were able to also understand differences across time and space. So as we get further away from the IED functioning, what are people doing? As people's location further away, what's happening? And then especially with Boston, we get some information about what happens when there's multiple attacks. So a lot of the events where we get information where there was a single explosion, people actually react a lot differently when there's multiple explosions. And we see this in the eyewitness statements where there's one explosion, people don't react quite as quickly. They don't know what's going on. It could have been an accident. When there's 2 explosions, people immediately react then with the second explosion, understanding that at that point it wasn't an accident. It was actually some type of targeted attack.
When you model, you have to be comfortable, know that there are so many other factors that are important, but we don't have data for that. We cannot include everything because it just gets too complex to model. We cannot execute it anymore. So we needed to look at these videos and say, what is important about these videos? What is it important about this behavior? And so, for example, when you look at the Boston Marathon, you see the first explosion and the runners, they actually just move away and then keep running. And a lot of people just freeze and before they actually do something. And that informed our way of what we need to model. So basically what it boils down to is that people are moving and people are acting. And there's a certain moment where just the frozenness, the effective, okay, so what just happened turns into, oh, now I can decide what I'm going to do. And people start either evacuating or they stop and gawk. So these were the things that we pulled out of these videos. And we formalized it a little bit. Can we now look at the next slide, the one that says modeling human behavior? Okay, so these are some of the assumptions that we make. And of course, these assumptions and our approach, they determine then how we implement it and the tools we're going to use. There's so many tools. And the one we chose is a bottom-up approach. So it's not a statistical approach where you aggregate and then derive knowledge from that. Ours is a bottom-up approach where we really model every individual. And because we model every individual, and as Will pointed out earlier, we have different kinds of types. So we have spectators, we have runners, we have law enforcement. So every individual has to act. And as you see on that slide, that people move, they have a certain target, so they move. So we have to model that people move and they move towards something. It's not erratic how they move towards something. And they also move at a certain speed. So yeah, in the Boston example, it was easy. Of course, runners are faster, but people walk at a certain speed, I think 3 miles per hour or something. And elderly people move slower than adults and than kids. So we need to model movement. Then the other thing is that there's a strong social component. So some people start moving and other people, they don't necessarily need to know what's going on. They just see their neighbor is moving, so they move as well. So there's a strong social component. So we model that as well. But of course, individuals don't want to bump into each other. So they try to keep a certain distance. So the whole crowd is moving, individuals are moving, but also individuals try to avoid each other. And so once we get beyond the movement, people act. And as we saw there in that video, once they get out of the frozen stage, okay, they still acting fairly effectively. So emotional. So what just happened? And I need to get away from here or something. So for a brief moment, it's just this fleeing movement. Then after a while, it turns more into rational decision making. Okay, they actually got away. They look around, and okay, do I want to stay? Is it so dangerous or not? And as Will pointed out, behavior after 2 explosions is very different. First explosion could still have been a fluke or something. So a lot of people just stand around. So that what we call is then the rational. And then finally, what I mentioned earlier, the social impact. A lot of people around me moving. Okay, I'll better move as well. If people are standing around me, okay, it's probably safe. So I can also just stand around. So these are the things that filter into our model, into that decision module that, so the decision making that people have to make. Do I keep running? Do I flee? Do I help? And so on. And Will is now going to talk more about the different types of behaviors and the way we implemented it. And then I will get into more detail about agent-based modeling.
Yeah, so I think one of the things that Rainer talked about that I think is important is kind of what does our site partners, what do they get out of this? And we had a visit a couple of weeks ago with Office for Bombing Prevention, our site partner, showing them the results of the modeling. So, we were showing them video of the model and the simulation and talking about the fleeing and, the types of behaviors that are people engaged in and where they get piled up at the exits and the entrances and things like that. And I think one of the important things for those partners is that they get this information prior to an event actually occurring. And Office for Bombing Prevention is pretty good at explaining this to them. And it's a lot of times you don't get information about what people are going to do or how you can protect soft targets or how you can do things better with your policies and procedures until after an event occurs, when you have an after action report. And so one of the things that I think we've been able to provide by doing the modeling is that we're able to say ahead of time, this is what we think would occur, and this is how then you can change some of your environmental setup around your venue to help make sure that people aren't hurt in crush events, or people aren't injured fleeing, or to know where to station your first responders, your EMTs. And we get that information because from the case studies, we're able to determine kind of the distribution of what we think should occur within these larger environments. And so the behaviors that we saw within the case studies, so fleeing, we had people, we call it gawking, but a lot of times you have people who are just standing around. They're in the way of first responders. They're taking pictures. They might be frozen. They might not be able to move. We have people who hide. So they might end up in different locations throughout the environment and they're not doing anything. And first responders need to know that when they show up, that there could be people in places that they just wouldn't expect them who ended up there and then are too scared to move or to leave. One of the behaviors that we found within the case studies that we put in the model that is interesting is a helping behavior. And in the calibrations, we make law enforcement and EMTs, their job is to help. And in all the case studies that we look at, that's what first responders do, almost without exception. The explosion goes off and they head towards it to help. You see that in the Boston Marathon bombing video. The first thing law enforcement on site is doing is heading towards the explosion that's only 30 feet away from them. And so we build that into it, but we also have a lot of citizens in the case studies who are also helping and engaged in this behavior. So we build that into the modeling too, that there's a percentage of individuals who are on site that are helping, and they might be individuals who are there and somebody that they love or they're with is injured, so they stay and they help and they're assisting first responders. It might be individuals who have training. They might be medical personnel. They could be doctors. They will move throughout the environment to get to it to help also. And the helping is a really interesting behavior that we've identified. And we've talked a little bit about how law enforcement can prepare and other first responders can prepare, knowing that when they show up, there will be helpers there. It's not a large number, but it's enough that you could use that in assistance and know that there will be people there helping and be trained in trying to figure out how to have them help you out also on site. So those are the behaviors that we kind of found from the case studies and got really kind of estimates of how often we think that occurs based on eyewitness statements, based on video footage or photographic footage of the case studies. Other information that we got from the case studies that we built into the modeling, we wanted to think about how behaviors change across time and space. The Office for Bombing Prevention was very specific because their mandate is to talk about, they call it everything left to boom. So they're not supposed to look at anything after the explosion. That's FBI, ATF, other first responders. They're supposed to prepare people for everything that happens before it. However, in order for them to understand and help people prepare, they see value in these types of projects that are looking after the explosion, but they wanted to make sure that we were only modeling the first basically 2 to 3 minutes after the explosion. So our models look at what happens immediately afterwards before off-site first responders would actually show up. So in cases like the Boston Marathon bombing, fortunately, there were a lot of first responders already on site, so they are part of the model, and we get to see how they act and how they react to what's going on. But our model, the time horizon stops at about 3 minutes for our modeling, especially for outdoor venues. Indoor venues, it stops a little bit sooner because things settle down a lot quicker in an indoor venue once something occurs. But so we had to think through how can we capture across time and space, and the agent-based modeling that we're doing does a really good job and is actually built to do that. And so from the case studies, we pulled out information, decided, all right, well, there's different types of behaviors that we expect to occur based on the distance away from the IED and where it functions. So we have what we call concentric zones. So in the primary concentric zone, that is the blast radius. So we expect the behaviors in there to be different than the secondary concentric zone. And that's an area where you can see what's happening, where the IED functions, but you weren't injured and you were not in a situation where you could have been injured because you're outside of the blast site. Then we have tertiary concentric zones, and those behaviors are very different. So law enforcement, as they show up, should understand that there are different types of behaviors that they will engage in based on how far away they are from the explosion. And people in the tertiary concentric zone, there might be more people gawking. There might be more people who have fled from the secondary zone into the tertiary. or from the tertiary into the evacuated zone. So the evacuated zone basically being you're far enough away that the impact from the explosion psychologically and emotionally and physically has kind of dissipated, and you're in a place where you're starting to shift back to kind of a pre-event behavior. So that was one of the ways that we tried to calibrate and think about behaviors across time or across distance. And then we also
Before you get to time, there's one aspect that we implicitly talked a lot about, and that's the environment. And when the movement of people is constrained by the environment, the actions is constrained by if it's indoors, if it's outdoors. If there's an explosion, the knowledge you have, okay, if it's a big outdoor venue, you can see there might have been something or there was an explosion. If you're indoors, all the information is you heard something or you see people running. So a big aspect, and you will see that in the demo, and that also was important for the selection of the tools that we used. We not only modeling human behavior, but human behavior constrained by the environment. So are there doors, are there walls, streets, side streets? So that's a very important aspect. If this kind of modeling really needs to look at the interaction between agents, but also agents and the environment, that's extremely important.
Yeah, and some of the outcomes that we found in our modeling, actually, to Reiner's point, there actually is a pretty big difference in what we were seeing based on the environment and how much might be between the IED and where people have to get to the exits, whether the exits are well marked, how many exits there are. So the environment, definitely plays a huge role in that. And then we also talked about the temporal phases, and this is basically us during the modeling determining that there should be certain times where people's behaviors change. So you have what we call microphase 1, and you have basically what we call impulsive reactions. So within the first 10 seconds after an IED functions, people aren't really making thoughtful decisions. They're just reacting to the explosion. They're reacting to what people around them are doing. Then they transition to the ability. There's still a large percentage of people who might be making effective decisions, especially if you start engaging in a behavior like fleeing. You're going to continue in that behavior until you reach a space where you feel safe. And that can last up to a minute, but people will start shifting over to more what we call rational. And we've had lots of discussions about rational effective means, which don't really matter at the end of the day for stuff like this. But so people shift over to a kind of a rational decision-making behavior. They start to calm down. So if you're showing up 10 seconds after an explosion compared to 3 minutes after an explosion, you will see a different, the crowds that you're meeting, depending how far away they are, they will be engaging in different types of actions based on that. And then when we get to, this deliberative, which is about 1 to 3 minutes after the explosion, people have decided, are they going to help? Are they going to flee? Are they standing there? Now, there will still be people who are frozen in place and aren't able to make a decision. So there is a percentage of that, but a lot of people have then engaged in kind of like a thoughtful process of what can I do now? Do I need to get to safety? Is that impacted by whether or not you're with family or friends? And so we try to build all this into the model as we were working through it. And then with the agent-based modeling, so we'll just talk a little bit about what agent-based modeling is and what it means. So Reiner, if you want to do that, and then I think Nate will want to add something once we're done with this slide. So
before we get to the gory details, are there any questions in the room about our approach, the assumption about what you've heard? You need to model behavior, environment.
Thank you.
Was there anything apart from paramedics, first responders, police officers? What was the pattern that you observed with civilians? Who was most likely to act in a helping manner and who wasn't? Was there a pattern that was identified? So not people with training, but untrained civilians.
Yeah. So in the case studies, and that's actually a great question. Now the data from the case studies is biased because we're getting limited amounts of information, right, from it. I would say that people that would help would be people that were closer, people who had some type of medical training prior. And it varies too, because I'm thinking about like Madrid now. There were people from the neighborhoods that actually probably were a half mile away and then showed up to the blast site. So you actually had people who were bringing medical supplies and blankets and things from their homes who showed up actually faster than first responders did. So I do think that varies. I think it also will vary. You know, the train stations in Madrid, they were open, they were public, it was easier to get into. As opposed to somewhere like Manchester Arena, where it's a enclosed space, and everybody was trying to get out of it because of one, you don't know what else is going to happen, and I think psychologically, once you remove yourself from that space where the event occurred, you probably feel safer, right? But as far as like systematically, the people that kind of stepped up to help compared to the people that didn't. I think a lot of it had to do with whether or not they felt they had some type of prior training, and then also whether or not they felt there was someone else around who could help or not. So in the London Metro Underground bombings, in some of the cases, it took 20 to 30 minutes before first responders showed up underground. And in those cases, you see from the eyewitness statements that people were saying, well, I didn't think I could have helped, but there was no one else around to help. So you actually see people who didn't have any training, but because they felt there was no one else who could step up to do it, they stepped up to do it. So yeah, I mean, that probably doesn't answer your question, but there was it was environment dependent a lot, and also the context of the bombing itself. Now, when there was multiple explosions, most people left as quickly as they could, unless somebody was there that they were with who had been injured. Or even cases where people didn't know the person who was injured, but the person was like, "Can you stay here with me?" They would stay. So I mean, a lot of civilians were willing to stay and keep themselves in danger, not knowing what else was going on, to help people around them. So,
And to just add what Will just said, so not who helped, but the patterns we observed, the way helping then actually played out. So one was depending on the blast size. If it was smaller, people actually helped everyone. But if there were a lot of injuries, it was much more that the people helped that they were closest to, meaning on the outside. So no one really, or only very few helpers got to the inside where people were injured. Whereas with a smaller blast, because there were so many people around, they helped everyone. So that was one pattern. And the other one is that with 2 IEDs, we had fewer helpers. So that the first blast, that's the general pattern was one blast. Okay, was it really or so? It's fairly safe to stay. But the moment there's a second blast, people know, okay, there's something going on, and we observe fewer helpers. And I think that's exactly the power of these simulations, that you can make it explicit what happens afterwards, and what to expect when first responders get there, and they can expect if it was a really big blast, there are probably a lot of injuries inside where no one has been helping.
So I had a question. So when you have terrorism, targeted violence, there are really high profile cases, and the goal is to cause mass mayhem, casualties oftentimes. So what we see a lot is a bit of learning and evolving on the side of the perpetrator. So for example, with I believe it was the Parkland shooting, where the school went into lockdown and the shooter then pulled the fire alarm to get people out. How do you kind of factor in this potential evolution and learning when you're trying to anticipate and build these kinds of simulations?
yeah, that's a great question. So for the IED simulations, we worked with our site partners and the law enforcement groups that work with them to kind of determine what they thought were their largest vulnerabilities. And actually, when we run the models, there were times that we were like, oh, if we make this public, then everybody knows the best way to blow something up, and have the largest impact. So on our side, with the IEDs, in order for us to model what we thought was the most likely event, we worked with the site partners to identify that. Now, for the next phase, where we actually, so with the IEDs, we didn't model offender behavior. so for the next phase where we will have an active shooter, we will model offender behavior. And in that, we will actually have the ability to say, all right, what if this person is familiar with the environment, which means they probably can move through the environment faster. They can take advantage of situations if they know, like with Alice training or run, hide, fight, what they expect people to be doing. So we could actually say, in this case, we're going to run the model and the offender is not familiar with any of this. And in this case, the offender is very familiar. And so they're more deadly. They can move through the environment faster. They can find victims quicker. So we can actually build all that into the offender behavior in the modeling. So
Yeah, I think that's a great question too. And that I think in the Boston Marathon bombing, you see the Tsarnaev brothers using that because the first they have the first detonation goes off, and then I think they wait like 15 seconds, about 200 yards away, near a logical place for folks to go. They trigger the second, they detonate the second one. So they were intentionally using the first bomb, to do damage, to confuse folks, and then they had an idea of what direction people would head, and they already had that bomb placed, and then they sat there, with a detonator, and were able, once they had enough people there, to hit that switch to blow that up. So they were already kind of factoring that in, and we saw that in, I think, some French bombings, and then even in the Belgium train and airport bombings as well, that terrorists were using that.
And unfortunately, we cannot show you results we have with some of the specific sites, but if you could see that, what our model showed, and we fairly quickly realized, okay, this can be really dangerous if that knowledge gets out, because people flee, and they flee to the exits they know. So there might be 5 other exits, but they got in through a certain exit, and that's where they all head. So we suddenly have these paths, and you have these choke points. So if we let the simulation run for a minute, you see paths, you see choke points. So basically all you would have to do is run our simulation. Okay, wait 30 seconds, put it there, wait another 30 seconds, put it there. So that's what really our simulation showed, where these choke points are. So we're not putting in the model right now, but that's definitely something we could do to say, okay, what if we were to put it here? Because we know it's similar to a heat map. So where it's really dark red, where most people are, that's where you place an IED. And yeah, we could play these what if games.
So I'm going to check it with Nate, and then we'll do just a quick overview of agent-based modeling so we can talk about the results and the takeaways. But Nate, did you want to add anything?
Sure. I think the big thing that from our perspective at DHS that this kind of approach allows us to do is really study those small N events, whether it's the kind of the behavior of crowds after an event were to occur, or the targeting decisions of the offender. It provides us that benefit to study these kinds of events. And since, we can't target harden our way out of this problem, and soft targets are always going to be at risk, this kind of ABM and agent-based modeling helps us figure out how to use our resources more effectively. So, overall, this kind of approach allows us to study those high consequence, rare events, and this is why it's a lot of value. So, thanks. Back to you.
So we're just going to quickly just go through what agent-based modeling is. And then we'll show you the mock-up of the Boston Marathon bombing simulation that we did, which was kind of our proof of concept before we started putting the behaviors and the agents into the environments for the partners that we were working with. But just quickly, agent-based modeling, it's a computer simulation technique that allows us to put individuals, which we call agents, into a 3-dimensional space, and basically model how they interact with each other, how they interact with the environment, what their behaviors are doing. There's a lot of research on this that is for kind of evacuation modeling. So when large buildings are designed, they will do agent-based modeling and show that everybody can evacuate and how they could evacuate in an emergency. And in those modeling techniques with the evacuation modeling, it's basically if you have a person in one location in your environment, how quickly can they get out, knowing that they have to interact with other people and they have to get in line between other people who are also trying to evacuate. And so let's say a stadium was being built, they would do the evacuation modeling to make sure that in an emergency, people can get out in a certain period of time. Now with that, it's everybody's moving and doing everything they're supposed to at the speed they're supposed to. following orders, exactly how they would. So it's basically the most effective, best case scenario for getting everybody out of the building. And so we're using the underlying information for our modeling, but we've layered on top of that actually decision making by people. So we're saying that if an explosion goes off, you're not going to stand there and say, what is the fastest way and the quickest way to get out? And then everyone's going to do that. And that's why we were looking at the different behaviors from the case studies, because we know people are going to flee, they're going to freeze, they're going to hide, they're going to help. They might just stand there and take pictures with their phones. And so we had to say, what happens when you put that on top of this just normal modeling? And so in the other simulations that we're doing, so Reiner talked about like a heat map, you can see like in these large event spaces, how people are running. We actually build in crush behavior. So if too many people are trying to get out one location, they back up. And if too many people are backed up, then you start getting injuries from crush behaviors. So you start seeing all these. And so that's kind of our contribution to this literature, is that we're saying that people just aren't going to go directly to find their way out. All these other things are going to occur. And if you're a manager at one of these spaces, if you do security or law enforcement for these spaces and these types of events, you need to know what's really going to happen, not the best case scenario if everyone's trying to get out. And so agent-based modeling allows us to do that. It allows us to put in different types of agents. So we actually can do civilians, law enforcement, doctors. We're working with a hospital, so we can put in nurses. We can have trained and untrained personnel within that. We can have security as opposed to law enforcement, and we can calibrate all those behaviors differently, because we would expect, based on levels of training, that these different types of agents will act differently. And then these are just examples of, so in addition to that, you can build into it as a civilian interacts with a law enforcement agent, they actually might act differently than they're interacting with other civilians. And then also it'll calibrate in how people move through the space differently, in the environment differently. That's all built into the modeling. For us, the types of data that we had to collect, we had to figure out how many agents might be in an environment. So we worked with our site partners on that. So if they wanted to model a very specific event at their location, we would find out how many people would be there, where they would be within that environment, what types of behaviors would they be engaging in, what are their goals in that environment? Are they just standing there watching something, or are they trying to get somewhere? So we had to know how to place people throughout the environment and what their goals would be. And then we had different information for the IEDs. So for the site partners we're working with now, we would do 3 scenarios. One would be a person-born IED scenario. The second one would be 2 person-born IEDs. So they're going off 10 seconds apart. We can vary that if we needed to. So we had to decide where to place those, and that's where we worked with security personnel and law enforcement to determine the best placement for what they thought their weaknesses were within the environments. And then we also had a vehicle-borne IED in our 2 outdoor environments. We're not doing vehicle-borne IEDs for indoor environments because of the amount of destruction, there just wouldn't be any behavior to model afterwards. And so as we were building all this and thinking through all this, we did basically a kind of a proof of concept with Boston. And so we did this about, I guess, over a year ago, a year and a half ago, where we built the simulation. I don't know if it's a plane. Yeah. It may or may not be playing. And I probably just reset it by doing that. But so what we're looking at is we're just looking we're looking down on basically the finish line of the Boston Marathon bombing. And what it is you see in the middle, it's the street, and we have runners who are running. Below it, we have people in the stands. So if you think about the video that we were looking at, to the left were the people in the stands in watching, and to the right, you had people in the location, which is where the ID is. Yeah, well, doesn't look like it's running right now. So what we did was we got the number of people who were involved in each of the situation of the different locations. So we determined how many agents to place in each of those, and we had the timing for the IED, and then estimated the size of the IED within the environment. And then we also have the second IED going off about 10 to 15 seconds after the first IED. And so that's it. What you'll see then is that people start changing color. So we color coded just so we could tell what behaviors were occurring. And so the yellow would be people fleeing. The red are people who are injured. We have casualty counts, so they might either be injured or killed. And then we have green, which is helping. And so with that, we have law enforcement. We also built in law enforcement, so we have those. And we were able to basically calibrate the modeling that we were working with by building this and saying, all right, if what we're building is working the way it's supposed to, we should be able to look at this in an event where it actually occurred and we had data on it, such as the Boston Marathon bombing. And then we're more confident that once we put this modeling into other environments, that the outcomes that we're seeing are actually going to be realistic outcomes. And so it's I guess it's just
It is moving, but very, very
Yeah.
slow.
This one's about for this section it might be about 2,000 or 3,000. I think it's just a video issue. But one of the environments that we're working with is 50,000 people. So it just depends on who we're working with and the events that they want to have us work with. And so we modeled maybe 30 seconds here, but afterwards we were able to get a good idea that actually this was doing what we thought it was going to do, and we could put it in different environments, in different locations, and we would be more confident that the results that we're seeing and the behaviors that we're actually modeling are real. So,
And just to reiterate, this is a prototype. So the real thing, we actually have Google satellite images, we have blueprints. So this you would and we're working on improving the Boston again, but you actually see buildings, you see the street, you see cars, and it actually, so this is only a side of the first explosion. We will extend that to the second explosion as well. So this looks a little bit unimpressive, but the real thing with satellite images and blueprints is so much better and so much more realistic than what you see here. And the second thing, one of the biggest challenges we face, simulating 50,000 agents, and they need to run and change behavior, is computationally very expensive. So usually when other simulations, they run a minute, ours run an hour, 2 hours, because there are so many computations going on.
So in interest of time, I'm just gonna go to kind of some of the takeaways that we handed off to our site partners, and these were exterior venues, large exterior venues, and after we did the modeling, talking through with them what we found and what we thought was interesting or might be useful to them. So one of the main takeaways was that crowd behaviors are predictable and they can inform the security protocols for these sites. So some of the stuff that we found, crowd behaviors will spread, having the potential to both aggravate and mitigate the situation. So what we found in the modeling is, so if you had a group fleeing into another group, you would actually activate the fleeing behavior in that group that was further away. And so the larger the number of the people that were fleeing. So one of the venues we worked with had a very large kind of space that was basically like a large field and had thousands of people in it. And so when the IED detonates and people start to flee away from the bomb, that actually then spreads into more chaotic behavior. And then you, instead of having the people that were just around the explosion trying to get away to safety, you have, thousands or tens of thousands of people fleeing, trying to get out of your exits, and then the issues that occur with that. Crowd behaviors change based on distances, which I talked a little bit about with the case studies, so that we see that depending on the time after the explosion or the distance away from the explosion, we do expect different types of behaviors to occur. Individuals such as law enforcement, security personnel can use this information to determine what they should be doing during that time. Even citizens could, if you know through some type of preparation before an event what would happen or what you should do or what the crowd would do, you actually can then use that information. So One of the venues that we had, which is extremely large, has a lot of on-site law enforcement during large events. And it actually, through the 3 to 5 minute run that we were simulating, law enforcement actually couldn't even get to the IED site in that time. And so in cases like that, if you know where the crowd is going to be and where it's going to be moving, but law enforcement needs to get to where the IED functioned, you can use this information to determine the best way to kind of go around it. And in some cases, depending on the location, off-site first responders actually might get there faster than on-site first responders just because of crowd movement and behavior. Another thing related to this was the blast site does not empty out. So you would think that what would happen is that everyone just gets away from the explosion as quickly as possible, and that's not what happens. So first responders showing up should expect that at a blast site, there's going to be obviously the injured people, but you're also going to have a lot of people there who are helping, who are family members or friends, and then also people who are just watching and, you know, taking cell phone video or maybe just standing there in the way. And Nate, I think you wanted to add a little bit to this slide.
Yes, thank you, Will. I just wanted to quickly kind of both in reference to these findings in particular and some of the other findings in this project about what these key takeaways mean for us at S&T and what we can take away from them. And I'm going to kind of put on 2 different hats here. The first is from the Office of Bombing Prevention. You know, it was relayed to me, and I'd like to convey that to you, that, you know, this is going to help them figure out how to set up protective measures, which can be implemented by these venues and other venues that can take advantage of this kind of modeling, and help identify how first responders can respond. And from an S&T perspective, you know, we see this as beneficial to training, you know, helping event staff prepare for evacuations and crowd behavior if something were to occur. As Will had mentioned, pre-positioning resources to allow for more efficient and effective response. You know, also there's potential of adjusting the security practices around specific areas that are higher risk and therefore higher vulnerability. And, you know, as Will mentioned before, you know, we can potentially train responders to more quickly reach injured persons by using those least traveled pathways based on those simulations. You know, all these findings are really helpful to us, and as I mentioned before, really help us understand these rare events. So thank you, Will. Back to you.
Thanks, Nate. So just really quickly, just in the interest of time, in case there's any questions, you know, some of the other things that we talked about with our sites was, you know, the impact of their physical environment. You know, if you're trying to get 10,000 people out of 2 exits, this is what you're going to see. However, if you have emergency exits, and so we could build this and we have built this into the modeling, where you might have emergency exits that are only opened in case of emergency. This is what the crowd looks like and how they get out after, if you open at 30 seconds or if you have to wait till a minute to open those exits, and how that alleviates pressure with the crowd behaviors and movements. And so the physical environment, you see a lot of differences in the modeling. And so, you know, the Office for Bombing Prevention has talked about trying to expand this so that they can provide this as a service to larger sites, because the takeaways that we get, yes, there's some high-level takeaways that you can say this should happen in your site, but until you actually put the modeling into your actual site, you're not going to see some of the nuances of the behaviors that are occurring. And then the other thing, too, was the changes in the IED size, number, and placement have a huge impact on the crowd behaviors. You know, one of our environments, we had a 1,000-pound vehicle-borne IED, and we compared the results of the crowd movement with that to the results of 2 IEDs. And the 2 IED actually ended up having larger places where there were choke points and people being injured trying to get out, because the movement in the crowd was actually much larger and people were fleeing at a higher rate when it was 2 IEDs, because the 2 IEDs signal to them that there's an ongoing threat. And it's not just that this was a once and done, and now you can figure out where to get to safety kind of in a slow and thoughtful way. Once there's 2 IEDs, everybody just assumes there could be 3, and that impacts the behavior. So
I think that's probably a good place to stop. I wanted to open it up for questions.
So we do have a question from online. The question is, can you share if this can work for active shooter situations?
whether it would work for active shooter. Oh yeah. And actually, so we're with our work with the Office for Bomb and Prevention, we're actually moving to a mixed modality modeling next, which would include an active shooter who also is using IEDs at the same time. With the active shooter, you add another component, which is the behaviors of the offender within it. And then in addition to that, you could also add law enforcement response. So we could actually model working with law enforcement to determine how they might approach a situation, and then varying that, are there 2 or 3 different ways that they might train how people should work or approach active shooter situations, and we could actually model those differently and then see which one has the better outcomes for civilians and law enforcement.
And that is also something interesting that we realize. The behavior from one IED to 2 IEDs is very different, but that's a discrete step. A shooter, that's an ongoing. So there's a continuum from 1 IED, 2 IEDs, 3, and a shooter.
Okay, other question back here. They're gonna get you a mic so folks online can hear. Yeah, sorry.
From your study, are there implications for city planners or event planners in preparation for the potential for an event?
I'd like to think there are. Yeah. So they're, thinking about policies and procedures and how you can set up environments where you have these types of events and the type of event that you're having at a soft target. Now, we've looked at specific events so far. We're also modeling we're working with a transit center. So we're modeling just routine behaviors throughout the day and that. And so I do think that there are ways that you can use that then to inform your policies and procedures. One of the site partners that we worked with, they said they do a lot, and I'm going to get this wrong, but they do a lot with a national organization that works with like fire code. And they said that with fire code, it's basically all based on your building. And so all your restrictions and your regulations are based on what the built environment is. And none of it takes into account what you actually think people would be doing during, a fire or a certain type of event. And so they talked about actually wanting to take some of this information to that organization to talk about what happens, if we actually take into account, and how does that impact your policies and your best practices and what you recommend people to do. So.
And that's actually a very important aspect of our model. So the behavior module, the way people make decisions, is independent of the environment. So if you give us a blueprint, if you say, okay, we want this kind of environment, we can take our agents, build the environment, plug them into environment, have to fine tune, of course, because what we realized, the behavior is different if it's indoors, if it's open space. But it is, as long as we get the blueprint, or as long as we get the architectural environment, the built environment, we can plug our agents in and run and see the results.
Right. Okay, I think we have time for one more question.
Yeah, I can go ahead.
Questions? Okay, Kevin.
So I guess one is, I don't know if this duplicates the last statement, but about just venues in general with large scale crowd movement. And he was thinking about I think it was a concert last year, where a number of individuals were killed just because of the rushing of the crowd to the stage. And so just movements of large people, how you think about setting up your venue, and then sort of these what if situations if people start to react to one. So it's not necessarily an IED, but it's just other types of crowd behavior. But the other point, I guess, and it's more of a question, is first responders aren't going to always respond the same way. And we know in some jurisdictions, maybe there's more planning and coordination to how they respond. So, could there be some ways to vary first responder behavior, maybe perhaps based on training and coordination? We know in London, they have a pretty sophisticated way of coordinating after large scale events, and maybe in other jurisdictions or other places, that's not the case. So even layering in those types of factors, not assuming first responders are always going to respond the same way in every place.
Yeah, we can definitely vary all that. And so, for examples of that, we could change the timing of when people show up. So then you could see, based on your average response time, if someone shows up at 30 seconds or 3 minutes or 10 minutes, what's going on and how does that impact then the outcome? We could also do things like randomizing where people show up. So if you're trained to show up at a specific spot because you've decided with the venue manager that this is the best place to show up in an event, you could see how showing up in one location on one side of it, and I'm thinking like really large locations at this point, but one side of like a stadium compared to the other side. So we could randomize where you show up and then how that impacts once you get inside, where you can get to different places. And then eventually, the outcome is how safe are people, right? And so we could see all that, how many people might be injured, especially in like an active shooter situation, but also with IEDs, like how does that then impact our positive outcomes of people being helped or EMTs getting to them faster and things like that. So.
And to get back to your first question, another aspect of our model is we're not just modeling injury of people, but fear. And fear has a much more distant effect. So injury is the blast radius, but fear can affect many more people, and fear drives the effective decision making. And so that's an aspect of our model.
Thanks for that. I think with that, our presentation is over. I want to thank everybody and thank our panelists.